Hi, good morning. Welcome to today's talk about Gauss Law. What is Gauss Law? The Gauss Law is introduced by Gauss scientists to find out electric field in different systems or patterns or areas. So, according to Gauss Law, the total flux linked with a closed surface is equal to 1 by epsilon naught times to the charge enclosed by the closed surface. That means in a closed surface, whatever electric flux is generated, the electric flux is equal to 1 by epsilon naught times to the given charge. So in mathematically, it represented as closed surface, closed line integral A dot ds equal to 1 by epsilon naught into q, or phi equal to q by epsilon naught, where phi is electric flux. The units of electric flux Newton meter square per coulomb. Charge q is the enclosed charge. Epsilon is permittivity of free space. So this is about the Gauss law statement and its formula. That means in a closed surface, what is closed surface? A surface without any edges. A surface without any edges is what? Closed surface. In a closed surface, whatever flux is generated, the flux is equal to 1 by epsilon naught times to the given charge. So here this is about the figure where E, R, Q and ds. Here the surface which using to explain Gauss theorem, that surface is called Gaussian surface. Now, and moreover, in briefly, what is Gauss theorem? The flow of electric field lines to the charges within the enclosed surface. The flow of electric field lines to the charges within the enclosed surface is nothing but Gauss theorem. So, in a Gauss theorem, if there are no charges enclosed by the surface, there are no charges enclosed by the charges, then what is net electric flux? The net electric flux is remain zero. How? Let's see here. That means that the number of electric field lines entering the surface is equal to the field lines leaving from the surface. So entering lines and leaving lines both are equal. That is the reason the electric flux is zero. We discussed already about this one. Gauss law can be used to simplify evolution of electric field in a simple way. In a simple way, we are going to evaluating electric field by using Gauss law. Let's see what we are going to evaluating. The electric field can be evaluated due to infinite wire. Because of the infinite wire, we are going to find electric field. Let's see. Let us consider an infinite long wire with linear charge density. Linear charge density lambda. What is linear charge density? Lambda equal to Q by L. Charge per length is called charge density. So the charge density lambda and length L. To calculate electric field in a infinite wire, we need to consider Gaussian surface. This is about the Gaussian surface. Length E, L E, Gaussian surface. So these are we have. This is about the Gaussian surface. So in the Gaussian surface, so by using this particular Gaussian surface, we are going to find the electric field. So already we discussed the charge density is equal to a ratio between charge per length. So Q by L is considered as charge density. So here it is what surface? It is a cylindrical surface. This is what type of surface? It is a cylindrical surface. So the surface, cylindrical surface area is what? The cylindrical surface area is considered as, in mathematical form, it is considered as 2 pi RL. 2 pi RL. So therefore, in this cylindrical shape, the net electric flux is considered as EDS. So in place of ds what? 2 pi surface. In place of ds we are going to consider 2 pi RL. So the net electric flux is E into 2 pi RL. But according to Gauss law, what is Gauss law? So the electric flux phi equal to Q by epsilon naught. So according to Gauss law, phi equal to Q by epsilon naught. So we already discussed what is phi electric flux. What is electric flux? The net electric flux is E into 2 pi RL. So E into 2 pi RL. So we already discussed what is Q value. So here lambda equal to Q by L. Then Q equal to lambda L. So lambda equal to Q by L, Q equal to lambda L. So charge density equal to ratio between charge per length. So charge equal to charge density into given length. So in place of Q we consider lambda L. So E into 2 pi RL equal to lambda L by epsilon. But what is your question? Your task is E electric field due to a infinite wire. So E equal to lambda by 2 pi epsilon naught R. So this is about the electric field evolution in an infinite wire. Now next task, electric field due to infinite plate sheet. Plate sheet. That about the previous. This is about cylindrical surface. Now this is about the sheet surface. So let us consider an infinite plane sheet with the surface charge density. Surface charge density. There we consider lambda. Here we are considering sigma. And cross sectional area. There we consider length. Here we are going to consider cross sectional area A. Then this is about the infinite sheet. See the arrow marks. So it is a Gaussian surface. So the arrow marks are moving away from the particular line. In both are in opposite direction. Here the direction of the electric field due to the infinite charge sheet is perpendicular to the plane. Perpendicular. So the direction of electric field is what? It is perpendicular to the plane of the sheet. So let we are considering cylindrical Gaussian surface. So according to the Gauss law, phi equal to what? The phi equal to Q by epsilon naught. Phi equal to Q by epsilon naught from a continuous charge distribution characteristics. So the net electric flux in the both ends can be considered as, see, the net electric flux is EA minus of minus EA. Why you considering the net electric flux? Consider electric flux from the two ends of the Gaussian. Here the net electric flux, whatever we need to consider, it must be considered from two sides. That's the reason the net electric flux from two sides is EA minus of EA, then minus minus plus, then phi equal to 2EA. So the net electric flux is 2EA. Then we can write, so according to Gaussian, phi equal to Q by epsilon naught 2. But what is phi? Phi is nothing but 2A. So Q is what? So the ratio between sigma equal to Q by A, then Q equal to sigma A. Here in place of Q we need to consider sigma A epsilon. Therefore E equal to A is cancelled, then E equal to sigma by 2 epsilon naught. This is about the electric field in infinite plate sheet as well as in infinite wire. So this is the task. Thank you.